Now I want to look at this subtopic, electrical work done in a given circuit. Electrical work is done when electric charges flow from one point to another of a conductor of different potentials. It means that as charges flow from a higher potential to a lower potential, you have it that electrical work has been done. Now, if Q is the quantity of electric charge that flows between 2 points of a conductor of potential difference V in volts, then the work done W is given by W equal to QV. Now, the charge flowing there is given to you as Q, and the potential difference is given to you as V. So the work done now will be the charge times the potential difference. Recall that I is given to you as Q over T, where I is equal to electric current, and the time T is time of the flow of electric current, while Q is what electric charge flowing. So if you cross multiply here, you have Q is equal to IT. Now substitute Q equal to IT into W equal to QV. That's this equation 1 here. So what do we have? You have W is equal to Q is IT. You have IT times V. But it is commonly written as W equal to IVT, not ITV. Is that okay? From Ohm's law, V is equal to IR. Substitute V equal to IR into W equal to IVT. So wherever you see V, you put what? IR. So we have W is equal to I already here times V is what? IR times IR. T here now remaining this T. So we have I times IR times T. So I times I gives you I squared. Now remaining RT, we have I squared R times T, giving you I squared RT. That is the second formula for work done, electrical work done. Since work done is equal to the energy expended in doing the work, the energy you use in doing the work must be equivalent to the work done, otherwise the work will not be done. So we have work done is equal to energy expended in doing the work. So we have that electrical work done is equal to electrical energy present in the circuit. So the kind of energy we're talking about here is electrical energy present in the what? Circuit. This electrical energy carried by moving charges can be converted into heat energy. Where do you see such example is seen in electric iron, electric kettle, which converts electrical energy to what? Heat energy. So from there we'll have that heat energy can be given to you as heat energy is equal to IVT, which is now the work done, also which is equal to I squared RT. We're equating the heat energy now to the work done, which is equal to IVT, the first one we have gotten, and the second one I squared RT. Now electrical power. This is the time rate at which electrical work is done, or it is the electrical energy expended per second. We say the time rate of electrical work done. That is electrical power. Remember, power is a work done over time taken, or time rate of doing work, or time rate of energy expended in doing that work. So now talking about electrical work done, say the time rate at which electrical work is done, or it is the electrical energy expended per second. So from that definition, we'll have the formula that P representing power is equal to electrical work done over the time taken. So we have P is equal to W representing work done, electrical work done, T representing time taken. So we have P is equal to W over T. But our first W today we got that work done is equal to IVT over T now from this formula. So if we cancel out here, T will cancel out against T. P now means electrical power is equal to IV, where V itself from Ohm's law is equal to IR. Now if you substitute this IR now into P equal to IV, we say substitute V equal to IR into P equal to IV. What do you have? P is equal to I is here. Now, this, whenever you see V, you put what? IR. So we have I times IR, giving you P is equal to I squared. I times I gives you I squared times R. That gives you P is equal to I squared what? R. Is that okay? Now, from Ohm's law, V also is equal to IR. Now, if you want to, you now make I, so just the formula here, I equal to V over R. Substitute I equal to V over R into P equal to IV. We've gotten that P is equal to IV. Now substitute I equal to V over R. Wherever you see I, you now put what? V over R. Is that okay? So we now have P is equal to, what they put here, we have V over R for what? I. Times, what is now remaining in the equation is V over 1. Is that okay? So we'll have V times V gives you V squared. R times 1 gives you what? R. So we'll have the next formula for P, the electrical power, to be V squared over R. So the SI unit of electrical power is still watts. Is that okay? Which is the SI units of power generally. Now, cells of electrical power. Electrical energy consumption is measured and sold by the Power Holding Company of Nigeria, this PHCN. And then this Power Holding Company of Nigeria installs meter which records the power consumption in kilowatts hour. That is the unit at which they record the power you consume in your house. While 1 kilowatt hour is the energy consumed by an appliance when a power of 1 kilowatt is used in 1 hour. Could be the energy consumed by your electric iron or electric stove. So the energy consumed by your appliance when a power of 1 kilowatt is used in 1 hour is known as 1 kilowatt hour. Is that okay? So PHCN sells electrical energy in Nigeria in this unit called kilowatts what? Hour. That's the unit at which they sell electrical energy. The energy consumed and its bill can be calculated with the formula total cost of operating an appliance equal to PCT over 1000. Now, where P is power in watts, this P represents power measured in watts, and then C here represents unit costs, a unit cost of what the energy you consumed, and then T here represents the time in hour, not in seconds. Is that okay? Now I want to see how we can use the formulas we have now derived to solve some problems finally. Calculations on electrical work done and electrical power. The first one, calculate the work done in moving a charge of 250 coulombs through a PD of 60 volts connected across the ends of the wire. Calculate the electrical work done. So the parameters given to us in this question will have the charge is 250 coulombs. Then the voltage there is 60 volts. So electrical work done will have the formula that W is equal to QV. If you substitute now, you have Q is 250 coulombs, that is the charge. Then the voltage is 60 volts. So 250 times 60 gives you 15,000 joules. Electrical work done is measured in the unit joules. Is that okay? Now example 2. Calculate the total electrical energy developed by an immersion heater with a voltage supply of 240 volts when a current of 10 ampere flows for 2 minutes. Electrical energy developed. Calculate the electrical energy developed. Now I want to see how to solve the problem. Solution, the parameters given to us will have the voltage is 240 volts. The current is 10 ampere. The time is 2 minutes. What's supposed to be in seconds? Talking about electrical energy, not power. So we'll have the time here is 2 minutes. We should now have to convert to seconds. 1 minute gives you 60 seconds. So 2 minutes gives you 2 times 60. That is 120 seconds. Are you following it? Okay, but electrical energy, remember the formula we see, is not converted to immersion heat. Electrical energy is converted to heat energy now. We'll now give you H is equal to IVT. So we'll have I, we'll have V, and we'll have T. That is why we're supposed to use this. We use this formula. So we want to substitute these parameters into the formula now. We have H is equal to I is 10, then the V is 240, and T is 120. If we multiply all of them all through, you have 288,000 joules, which is something that's writing 288 kilojoules. Is that okay? Okay, we want to look at example 3. Calculate the power of an electric kettle taking 5 amperes from 210 volts supply. So we have only 5 ampere given to us as the current, and the voltage is 210 volts. So what formula are we going to use to calculate the power? The power now, electrical power. We have P is equal to IV. So here we'll have I is 5 ampere and the voltage is 210 volts. So if you multiply through, you have 1050 watts. Is that okay? Now the number 4. An electric lamp is rated 36 watts, 12 volts. Full stop. Calculate the current in the lamp and the resistance of the lamp. So if you look at this, 36 watts represent the power here. P is 36 watts. The voltage is 12 volts. Calculate the current. We don't know the current. So if you look at the values given to us, you have P and you have IV. So I'm using P is equal to IV as the formula. So we want to find I. Now you divide through by what? V. So I is equal to P over V, such that P is 36 watts, the voltage is 12 volts. If you divide 36 by 12, you have 3. So the current here is what? 3 ampere. You have to calculate also the resistance of the lamp. Based on what you have, we're using the formula P is equal to V squared over R. So we have V given to us as 12 volts, and R we have calculated. We have R. We are looking for R. So you cross multiply here. I will have P. So PR is equal to V squared. So R is equal to V squared over P. So our V is 12 squared and our P is 36. So we have 12 squared gives you 144. Divided by 36, that gives you 4 ohms. Now example 5. An electric appliance takes 5 amperes when operated on a 220 volt supply. Find the cost of operating the appliance for 12 hours at 10 kobo per kilowatt hour. I'm talking about the cells of electric power, electric energy. So we'll have that I is equal to 5 ampere given to you in that question, and V is 220 volts. That is, the voltage is 220 volts. The time taken is 12 hours. And the unit cost there is 10 kobo. You are asked to find the cost of operating the appliance. First of all, I want to get the power. P is equal to IV here. P is equal to what? IV here. Because we want to get the formula that total cost is equal to PCT over 1000. We want to get the power first. It's not given to us. P is equal to IV. So I here is 5. The V is 220 volts. If you multiply all, you have 1100 watts. That is your P. But total cost is equal to PCT over 1000. So this P we have calculated now is 1100 watts. Now the unit cost is 10 kobo and the time is 12 hours divided by what? 1000 according to the formula. So if you multiply out all this value here and divide by 1000, you have 132 kobo, which if you convert to naira, in converting to naira, you divide by what? 100. And that gives you 132 divided by 100, and that gives you 1 naira 32 kobo. Is that okay? Now we are almost getting to the end of the topic. We want to see how we can test our knowledge on what we have discussed so far, to know whether you are really following what we are doing. Example, question number 1 says, define the term electric field. Question 2, list 3 properties of electric lines of force you know. Number 3, define the term electric current. Number 4, list 4 sources of generating electric currents. Number 5, state Ohm's law. 6, define ohmic substances and non-ohmic substances and give 1 example of each. Number 7, list 4 factors that affect electrical resistance of a metallic conductor. This is a circuit diagram which you ask to calculate the value of the X ohm here. You have 2 ohms, you have 3 ohms, you have 2 ohms, you have the current 2 ampere, and total voltage is 12 volts here. Now, number 9, a work of 30 joules is done in transferring 5 millicoulomb of charges from a point B to a point C in an electric field. What is the potential difference between B and C? Then finally define the term electrical power. I believe you've copied the questions down. If you have finished solving the question, the problems that you can now exchange with your friends, as to now look onto the boards for the answers to check whether what you have written down are correct. Now the solution to the questions you've copied. Number 1, you're asked to define the term electric field. It's a region around a charged body where electric force is felt. We have explained all these things before, and I just wanted for you to check whether what you've written down corresponds to what you have here. It's a region around a charged body where electric force is what? Felt. Is that what you've written down? You can mark for yourselves. Number 2, 3 properties of electric lines of force include: number 1, they start only from positive charges and end at the negative charges. Number 2, they do not overlap each other. Number 3, the closer the lines are, the stronger the electric field. Number 3, electric current. It is the time rate of flow of electric charges in a circuit. The time rate of flow of electric charges in a circuit. And it is given by the formula I is equal to Q over T, and where I is equal to electric current and Q is electric charge and T is time taken for the charge to flow in the circuit. Are you sure with the marking? Now I want to look at number 4. Sources of generating electric currents are, we have 4 ways or 4 methods. A, by chemical energy method. B, heat energy method, mechanical energy method, and then solar energy method. We have the following methods or sources of generating electric currents. Number 5, we're asked to state Ohm's law. Ohm's law states that the potential difference across the ends of a metallic conductor, that is a metallic wire, is directly proportional to the current passing through it, provided that the temperature and other physical conditions are kept constant. Now, mathematically, you can go ahead and prove it that V is proportional to I, and V is equal to IR, where your V is potential difference across the ends of the wire, and I is current passing through the metallic conductor, and R is resistance or opposition offered to the flow of current by the wire. Is that what you've written down? You can mark for yourselves. Number 6, ohmic substances are materials that obey Ohm's law. Meaning that the more the current, the more the potential difference. They obey Ohm's law. Examples, I have to give at least one example, have pure metals. The examples of ohmic substances. The next one, non-ohmic substances are materials that conduct electricity but do not obey Ohm's law. I've explained that before now. Examples are diodes, transistors, and so on. Number 7, factors that affect electrical resistance of a metallic conductor are 1, length of the conductor, 2, cross-sectional area of the conductor, 3, the temperature, the type or the nature of materials of the conductor. We're asked to list them. Now I want to look at question number 8 and its solution. We have these two resistors here, they are in parallel. I want to get the value of total resistance offered by these two resistors here and then redraw it and put it to be in series as we've done before now. Now you have here is the voltage, 12 volts. You have the current passing through or flowing in this circuit as 2 amperes. So you have this resistor here giving resistance of 2 ohms, and this one is also 2 ohms, and this one is 3 ohms. So I want to now, first of all, get the total resistance in what? Parallel. So we have R total in parallel. So we have 1 over R is equal to 1 over X ohms plus 1 over 3 ohms. You have the resistance, the resistors here are X ohms and 3 ohms in parallel. So to get the total resistance, now we'll have 1 over R equal to 1 over X plus 1 over 3. Now what is the LCM of X and 3? We'll have it as 3X. So 1 over R is equal to, now 3X is the LCM. X into 3X will now remain what? 3, because X will cancel out, remaining 3. 3 times 1 is 3. Now 3 into 3X, 3 will cancel out each other, remaining X. X times 1 gives you what? X. So we'll have 1 over 3 is equal to 3 plus X over 3X. So if we cross multiply, you have 3 times 1 is 3X equal to R into 3 plus X. Are you following it? Now divide both sides of the equation by 3 plus X so as make R subject of the formula. Now you have 3X divided by what? 3 plus X is equal to R into 3 plus X. This one you have here now, divided by what? 3 plus X. So this will cancel out this, remaining what? R. Therefore, R is equal to 3X over 3 plus X. Is that okay? That gives you now the R total in what? Parallel. We want to now redraw the circuit to see how it will look like. Now you have it as a single resistor, now having resistance 3X over 3 plus what? X. Then how do you get the value of X ohm from here? So we have redrawn it and we'll have it all to be in what? Series. Now I want to calculate R total in series. R total now will give you have R equal to 2 ohms. These 2 ohms here plus these 2 ohms here plus this is what we have in that page. Now you have 2 ohms plus 2 ohms plus 3X over 3 plus X. So R is equal to 2 ohms plus 2 ohms gives you 4 ohms. Over 1 is 4 ohms. Is that okay? Plus 3X over 3 plus X. But Ohm's law says that R is equal to V over I. V over what? I. So we have it that we have it here that 4 over 1, which is this one here, plus 3x over 3 plus x, that is this, is equal total voltage in the circuit is 12. Then total current is what? 2. You can see it here, the voltage is 12 and total current is what? 2. So following this Ohm's law here. So we have 4 over 1 plus 3x over 3 plus x equal to 6 over 1, because 2 here 1, 2 into 12 is what? 6. So we have 6 over 1. So collecting like times now, what do you have? We have 3x, which is this one, over 3 plus x is equal to 6 over 1 minus, this is plus 4, is plus here. If it crosses over the equality sign, it turns what? Minus. Now 6 over 1 minus 4 over 1, just like saying 6 minus 4. That gives you what? 2. Are you following it? So have 3x over 3 plus x is equal to 2 over what? 1. 1 to get x. So have 3x now, of course multiplying here, 3x is equal to 2 into 3 plus x. So you have 3x times 1 gives you 3x equal to 2 into 3 plus x. Is that okay? That is what we have here. So 3x is equal to 2 times 3 gives you 6. 2 times x gives you what? 2x. So like times again here you have 3x. This plus 2x crosses the equality sign gives you minus 2x. Is equal to what? 6. So 3x minus 2x gives you x, which is equal to what? 6. Therefore, the resistor x has resistance of what? 6 ohms. Is that okay? Then number 9 question, work done. You're given that the work done is equal to 30 joules. And the charge there is 5 millicoulomb, which means milli means 5 times 10 raised to the power minus 3. 5 millicoulombs means 5 times 10 to the power minus 3 coulombs. So we're asked to get the potential difference between the 2 points there. So we'll have W is equal to QV, the formula we have already derived today. Therefore, V, which is now the potential difference, gives you work done over the charge. That is 30, which is 30 joules here, divided by 5 times 10 to the power minus 3. And this minus 3 goes up here now, is 10 to the power 3. So it will now give you 30 times 10 to the power 3 divided by 5. That gives you 30,000 over 5. And that gives you what? 6,000 volts. Is that okay? Then finally, we'll have electrical power. We have defined it before now. At the time rate at which electrical work is done. Or I will say is the electrical energy expended per second. Now you have finished marking for yourself. You can submit your notes so that I can cross-check what you've marked, whether they are right. Is that okay? Thank you very much. We've come to the end of the lesson. See you next time.